Hi, in this video, we'll learn how to create structured numpy arrays. As usual, let's import numpy first. Okay. In all the arrays up to now, we've had homogeneous data, so data of one and the same type, like all ints or all floats. But we can also define structured arrays with columns of different types. Let's say we want to implement the following table as an array. Here we have 4 columns: name, occupation, age, and income. Using dtype, we can define a different data type for each column. As you can see, we'll need strings for the first 2 columns and integers for the other 2. First, let's define a single column, for example the age column, and populate it. We can do it like so. Ages equals np-array. Here we have the ages as one-element tuples, and the dtype is set to I1, which means 1 byte integer. We can access the data in the age column by key. So, print ages age. Here is the key. And here's the data. For better readability, we could assign the data type to a variable. So let's create the age variable and assign the data type to it, like so. Age, this is the key, and this is the type, I1, 1 byte integer. And now we can define ages using this data type. We can do it like so. Ages equals np-array, and so on. Well, it's all exactly the same as before, but this time dtype is set to age. This variable was defined before. Again, we can access the data in the age column by key. So print ages, and the key is age. Here's the output. Now we're ready to create our structured array. Here's the code in which we create and use the structured array. Let's define a data type and assign it to a variable. The data type is worker. We want the strings to be 20-character Unicode strings, so we should use the string U20. Here and here. The age should be a 1 byte integer, and the income should be a 4 byte integer. Okay. And now we can use this data type in our array. Workers array equals np-array, and here we have John Smith, the dentist. Here's the age, here's the income. And we have all the 4 entries here, and the dtype is set to worker. So this is our dtype. We can access the data by row, by column, or individually. If you need a whole row, just use the index of that row. So, if you need the second row, you should use the index 1. Have a look. Print second row. Print workers with index 1. Shift enter, and here we have it. Second row. Mike Turner, driver 50, 24,130. You can access a whole column by key, like before. Let's access the occupation column, for example. So, print the occupation column, workers with the key occupation. Let's run this code. The occupation column, dentist, driver, teacher, nurse. So here we have all the occupations. And now let's access the third item in the names column. So name index 2. And we have the third name, Lisa's tip. Or we can do it like so. Workers with index 2 and key name. We also have Lisa's tip in the output. Now, a slightly more complex example. Let's implement the following table as a structured array. We'll use the following types: int 32 for the box ID, float 64 for length, width, height, and price, int 16 for amount, Unicode 30 characters for item. This time, we don't use the string representations of the data types, but rather the full type names, so int 32 instead of I4, for example. For Unicode, we'll need the following syntax: np Unicode, 30. Fine. So, here's our implementation. First, the data type, box. This can be defined like so. Box equals np_dtype. Now, as our table was quite complex, we need all this nesting here. And now, here you can see the types of length, which is a float, width, height, these are all floats. Item is a 30-character Unicode string, amount is an integer, and price is a float. So, this is our data type. And now we can use this data type to create our numpy array, like so. Boxes equals numpy array. Here we have all the data structured just like in the table. And here finally we have our dtype set to box, which was defined here. Fine. So now let's print the last row. Boxes with index -1. Last row. Here we have the data from the last row. And now let's print the box ID column. We can do it like so. Boxes with the ID, box ID, which is defined here. The box ID column. Here we have the box IDs. And now the width column. To print the width column, we can use the following code. Boxes with two keys, size and width. Size and width inside size. The output is the width column. Here we have all the widths. How about the content columns? Here we have it. The content columns. Boxes with key content. Now content gives us 3 columns actually. And here's the output. Here we have the content columns: book, pencil, eraser. And how about the price in the second row? Print boxes, content, price, second row, so index 1. And the output is the price in row 2, 240. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.